term, a squared term and a square root, they seem to be vocab we confuse. Something squared gets larger. So like it's that number times itself. So 4 squared is 16. The square root of 16 is 4. So you have to watch how you say it. Something squared is itself times itself. A square root is the radical symbol that goes on the term. We are going to take squared items and square root them. I don't know. I felt the awkwardness. It was like emanating towards me.
That was so funny. She looks so cute.
I'm going to die.
Well, I worry about your future.
I should just keep some of my thoughts.
I agree.
Me too. There have been some very awkward moments in this
What do you always
classroom.
say about me?
It's so funny though.
All right, so you have a perfect square. A perfect square cancels a square root, does not have decimals. So I'm going to give you the most important, or the first 15 perfect squares. They're the ones we're going to see the most. A radical is what we call the square root symbol. It's called a radical because sometimes it's for something other than a square root. So you could have like a little 3 here, and then it's a cube root. Or you could have a 4, and it's a 4th root.
So I didn't even know how to do one of the problems on the math, or on the homework, and I photomathed it.
And it used square roots.
Yeah.
Why would you tell her that?
Well, it was only one problem. Like it ain't.
Here's the thing though too.
Like if I don't know how to do it.
It's so annoying when our phones beeped, so that's why I put the notifications turning off. All right, so the perfect squares are 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. I did. I did.
Wait, so the number on
Welcome to my class.
No, not because of that. I don't know why.
wait, so the number on top it corresponds with the that's the that's just
That would be the answer if you took the square root. Yeah.
0.
Are we good?
I'm not that wrong.
Well, I mean, you asked pretty.
All right, so I told you this only works in certain cases. It only works when the B value is 0. It only works when the B value is 0. So it needs to be ax squared plus c. You cannot have a linear bx term. You cannot have a linear or bx term. So you'll see what that means kind of like once I give you some problems. But if you think about standard form, it's ax squared plus bx plus c. You cannot have a term with just x. So you can have x squared terms, and you can have numbers, but you cannot have a term with an x. After. Oh, there you go.
Wait, where's this at?
Wait,
Like right underneath the perfect square.
okay.
You're good.
Wait, where? Oh.
It's your eyesight messed up today.
All right, and then in the table, you have 3 cases that are going to happen. No real solution, one real solution that is 0, or two real solutions that are the positive and negative square roots. Let's look at an example of each case. So you're going to have the case that is no real solutions. If you have a case that is no real solutions, then the k value will be negative when you simplify. So in that first example, you have x squared equals negative 5. X squared equals negative 5. Negative 5 is less than 0. Therefore, you have no real solution. So if you solve or isolate x squared and it is equal to a negative, that is the no solution case for these problems. Yeah. That would also be like if you were factoring and you had a sum of squares. Can you factor a sum of squares? That is prime. So this is the case where you have a sum of squares. If I get x squared equals 0, x times x equals 0, or 0 times 0 equals 0, as Calvin so graciously pointed out earlier.
Yes, ma'am.
All right, and then the last case is you have x squared equal to 7. Is 7 greater than 0? Yes. Therefore, you have two solutions, and those solutions are the positive square root and the negative square root. I wish I had an office chair and wheels up there. I could just wheel it around. My chair doesn't fit out from behind my desk, so I can't bring it up. Let's look at some examples. So for x squared equal to 81, I'm going to show you the old way, and I'm going to show you the new way. So the yesterday method, what was rule number 1? Perfect. So we would have to give 81. And then after it was like that, the last number is negative 81. The middle number is 0. So I need two numbers that multiply to negative 81 and add to 0. Negative 9 in that. So that factored as x minus 9, x plus 9. So then you set each of those equal to 0. And we got x equals 9 and x equals negative 9. The new way says don't change it from being equal to 0. You have x squared equals 81. Take the square root of both sides. So the square root is that little symbol. The square root cancels the square, which makes this x. When you take the square root of a number, it is the positive and negative of that number. So once again, I get x equals, and 81 is a perfect square from my chart. Square root of 81 is 9. So x equals plus or minus 9. Yes.
So does this only apply to stuff that has two terms?
Yes.
And for the ones like for new ones, do we have to show work?
Maybe?
Cause like
I don't know,
if you
like,
have
like,
the square root of like 64, I'm gonna know it's 8 or negative 8.
yeah, that's all you have to show.
Yeah.
So here we have 2x squared equals 32. The old way would have been to subtract 32 and then factor it. The new way says you have an x squared, but no x term. So we're going to isolate x squared. So to isolate x squared, we divide by 2. So your x squared has to be by itself. It cannot have a number in front. So you get x squared equal to 16. Now you take the square root of that. So the square root of both sides. And you get x equals plus or minus 4. It's both positive and negative because 4 times 4 is 16 and negative 4 times negative 4 is 16. Number 3. 600 or 600. 6x squared minus 486 is equal to 0. So again, you could factor it the old way, or you could do the new way because the b value is 0. So you'd say 6x squared equals 486 because you'd add it to the other side. Divide both sides by 6. And then the square root of 81 is 9, or do not lose both answers. You must have plus or minus. If you take a square root, you get a plus or minus. You take a square root, you get a plus or minus. So the goal is to isolate the squared stuff. So in this one, the squared stuff is in parentheses. So we're still isolating the squared stuff. So we're going to divide by how do you get rid of something squared? So you take the square root of both sides. When you take the square root, your value is positive or negative. The square root of the squared cancel, so that leaves x plus 4 equals plus or minus 3. I need to solve for x. So you would subtract 4 from both sides. But we know that it's equal to 2 numbers. So what you have to do is sort of split this into taking the positive 3 minus 4 and the negative 3 minus 4. So positive 3 minus 4 is negative 1. Negative 3 minus 4 is negative 7. So you have your 2 x's.
Oh, wow.
No, it's my computer being awful. No.
I just.
All right. And then we have 3x squared minus 9 equals 0. So in this case, you would add your 9 to both sides, divide by 3, This is the first case that when I take the square root, is 3 a perfect square? So my answer is going to stay plus or minus the square root of 3. If my answer is not a perfect square, it actually means that this wasn't factorable. No, you're just writing the answers. We are now at a point where we are solving.
Okay.
Go ahead. So, like, you know, some of these, like I showed you, you could factor as x plus 9, x minus 9. If you tried to factor this, you would take out a GCF of 3, and that would leave x squared minus 3. Well, 3 is not a perfect square, so, like, you can't factor it. So this technique is one of those ones that, like, there are times you have to use it. Okay, and then that last example is very similar to example number 4. You have to isolate the squared stuff. So we're going to divide both sides by 4. Ignore that. To get rid of something squared, you take the square root. And then you can split it. So it's x plus 4 equals positive 1. And x plus 4 equals negative 1. Subtracting 4 from both sides, we get x equals negative 3, and x is equal to negative 5. Yes, and it's just the front page that is your homework. The back is there in case you need space. So some of them, if we are removed tomorrow, we will do that next page. And then the next page would be your homework. And there will be a video posted on Teams. So again, if we are removed tomorrow, guys, where's the video going to be?
On Teams.
Yes. Now, if we are removed tomorrow and Friday, you will just turn all the work in Monday. Like, I will check everything Monday, the notes, the homework, and the other worksheet. Or Delta Math. I haven't decided what Friday would be.
I don't really care.
Delta Math really takes more than 20 minutes. This calculus takes more.
Well, it just, like, I haven't decided if Friday would be a Delta Math or the last page in here yet. I'll make that decision. My concern
Delta
with...
Math is more easy and easier for you.